Hello, welcome to the section of the chemistry tutor where we're going to continue working with balancing these redox reactions in a basic solution. So again, the basic idea is you pretend it's an acidic solution, do the same process, then add hydroxide ions to both sides, then combine to form water, and then cancel again. That's all you're doing. So let's go and get a little more practice with this problem right here. So here we have MnO4 negative plus C2O4 negative 2 charge goes to CO2 plus MnO2. So here is the guy. It's already a net ionic equation. You can see that because you have the ions there. So what we'll do is we'll say step 1 is done. So step 2 is the half reactions, writing the half reactions down. And we'll do that right now. So we have MnO4 going to MnO2. That's half reaction number 1. Half reaction number 2, C2O4 going to CO2. So that's the other half reaction. All right. And we don't balance anything yet. The step 2 is just writing that guy down. So step 3 is the initial balance. What I mean by that is balancing everything except for hydrogen and oxygen. So for the first reaction, this one, the manganese is already balanced. So we'll just write it down again. MnO4 negative goes to MnO2. This guy, we can balance the carbon. So we have C2O4, 2 negative, going to CO2. Here's 2 atoms of carbon. Here's only 1. So let's go ahead and do this and make that a 2. So we've balanced everything except for hydrogens and oxygen. So we're done with that step. All right, so the next step, step 4, is to balance oxygen with H2O. So we've done this many, many times so far. So we'll write the first half reaction down, MnO4 going to MnO2. So here we have 4 oxygens, here's 2 oxygens. So we need 2 more waters on the right-hand side. And here we're going to have some work to do, C2O4 going to 2CO2. So we see from this guy we have 4 oxygens and 4 oxygens, so that guy's already balanced with regard to oxygen, so we're done with step 4. Now step 5 is to balance the hydrogens with H2O. All right, and so what we'll have here, let's write this down, MnO4 goes to MnO2 plus 2H2O. All right, now we're trying to balance hydrogen, so we have 4 of them here. So we're pretending again that it's an acidic solution. So what we're going to have is adding 4 hydrogen ions right there. So we're done with that. Now let's go ahead and rewrite this guy, C2O4, 2 negative goes to 2CO2. There's no hydrogens anywhere, so we're done with that. All right. So let's go ahead and slide this guy over, and now that we've balanced everything except for H and O, and then we balance hydrogen and we balance oxygen, now it's time to balance the charge, which is always step number 6. So we'll balance charge with electrons. All right, we'll go back into purple. So we have 4 hydrogens, ions, plus MnO4 negative goes to MnO2 plus 2H2O, like this. All right, so now we calculate the charge on the left and on the right. We've done this a lot, so we'll just run through it. We have 4 minus 1, because this is in minus 1 with a coefficient there, so we have as a positive 3. And on the right-hand side, we have a 0, because this is 0 and this is 0, so that's right there. So if I want to bring these into balance, I'm going to have to add 3 electrons over here to drag this guy down back to 0. All right, now let's copy the second reaction. We have C2O4, 2 negative, going to 2CO2. So I'm going to calculate on the left. I have a charge, a net charge of -2, because there's just a coefficient there of 1. And over here, it's 0. So if I want to add electrons, I'm going to add it to the most positive side. I'm going to add 2 electrons here, because then that will drag this down to match the -2. So step 6 is complete. I've added electrons here and here to bring them into balance. Notice I had to add 3 electrons here, and on this side you're losing 2 electrons, so the gain loss between the two half reactions still needs to be corrected, and that's what we're going to do in step number 7. Step number 7, we're going to balance the electron gain loss. All right? We do that by multiplying, and then we're going to add these guys together. So, since these guys are not really multiples of each other, you're going to have to multiply both reactions by something. So I'm going to multiply the top one by 2. That's going to give me 6 electrons. I'm going to multiply the bottom one by 3. That's going to give me 6 electrons. So I'm going to do this, and I'm going to say multiply by 2. That's going to be my reminder. So I'm going to have 6 electrons, plus 2 times 4 is 8 hydrogen ions, plus 2 here, MnO4. 2 goes here, so 2 MnO2, and then 2 times 2 is 4 waters. All right, so we've multiplied that guy by 2. Let's switch colors to something we're not using. We'll do blue. This guy we're multiplying by 3. So we have 3 C2O4, 2 negative. And then we have 3 times 2 is 6 CO2. And then 3 times 2 is 6 electrons. So now we have two half reactions where we're gaining 6 electrons and losing 6 electrons. So that looks a whole lot better. So we'll add a plus like this, and we'll add everything together. So we have 6 electrons plus 8 hydrogen ions plus 2 MnO4 negatives plus this guy, which is 3 C2O4, 2 negatives. I don't have enough room to carry it all, so I'm just going to write over here 2 MnO2s plus 4 H2Os plus this guy 6 CO2s plus the 6 electrons off the end. So this is very, very close to the final answer if we were already in acidic solution, because the very last step for acidic is step 8, where we cancel. So let's go ahead and do that right now. So we'll have 6 electrons canceling with 6 electrons. I see my 8 hydrogen ions, but I don't have any over there, so I can't cancel them. I don't have any of these, and I don't have any of these. So really, this is the final answer if this were an acidic solution. This would be the final answer. But I'll put a little check mark there because we've canceled. But it's not our final answer because we need to do step 9, which is add the hydroxides to the left and on the right-hand side. How many do I need to add? I have 8 hydrogen ions, so I'm going to add 8 hydroxides to the left and 8 hydroxides to the right. If this were 3 hydrogen ions, I would be adding 3 hydroxides to the left and 3 to the right, and so on and so on. So you're basically just adding it like that. So what I'm going to have is 8 hydroxides plus 8 hydrogen ions plus 2 MnO4 negatives plus 3 C2O4 2 negatives. And here I'm going to have, let's give myself a little more room, 2 MnO2 plus 4 H2O plus 6 CO2. And then I have to add my 8 OH negatives because I have to add it to the left and also to the right. So that's what you would have on your paper. All right. Now, step 10 is to combine these guys wherever you can into water, right? Because 8 of these and 8 of these is going to give you 8 moles of water. So the next step, 9, form H2O. And when you do all of that, basically you're going to have 8 moles of water on the left. So what you're going to have is 8 H2O plus 2 MnO4 negatives plus 3 C2O4 2 negatives. And on the right-hand side, you're going to have 2 MnO2 plus 8 hydroxide ions plus 6 CO2. So all we've done is rewrite everything. We've combined the waters. Now, number 10 is to cancel. That's what we have to do left. And so What we now have is 8 waters and 4 waters, so all 4 of these waters can go, and we'll have 4 left over. And that is it. There's nothing else left to cancel because we've already had a cancellation step earlier in this set of problems. So just to have one nice answer to circle, we're going to have 4 H2O's plus 2 MnO4s with a negative ion there. 3 C2O4 2 negative, going to 2 MnO2s plus 8 hydroxides plus 6 CO2s. The water is now gone. So this is the final answer. Let's double check. 8 waters plus 2 MnO4s plus 3 C2O4s plus 2 MnO2s plus 8 OHs plus 6 CO2s. Now let's double check our answer as we always do. First, check the elements. We have 8 hydrogens on the left. We have 8 hydrogens on the right. We have 4 oxygens plus 8 more gives me 12. But then 12 plus another 12 gives me 24 oxygens. So I have 24 oxygens to balance. Here I have 8, right? Here I have 2 times 6, there's 12. There's 8, so that's 20. And then right there I have another 4. So 24 there, 24 there of the oxygens. I have 2 manganese, and I have 6 carbons, and I have 6 carbons. So elementally, everything balances fine. Now what we want to do next is check the charge. So on the left-hand side, what we're going to have, we have 0, we have -2, and we have -6 here. So we have -2 minus 6, -8 on the left-hand side. On the right-hand side, this is neutral, this is neutral, this gives me -8. So the charges balance on the left and on the right, the elements balance on the left and on the right. And as just sort of a double, triple check, at the end of the day, we should have hydroxides floating around because this is happening in a basic solution. So in my opinion, it doesn't really give us a lot to be gained by working a ton of extra redox reactions in basic solutions because, as we've seen, the procedure is the same. We work the same steps as we did for acidic solution, and we just do these last 3 things to kind of convert it, for lack of a better word, to reflect that this is really happening in a basic solution. So here's what your answer would be. You know how to check your work. Pat yourself on the back. We've done a lot of work with redox reactions, and believe me, when I learned this the first time, I was having a lot of problems with it. It can seem very complicated, but we've done enough problems, I think, so that you can see the process over and over and over and over and over again. Hopefully it's made its way up here and it's stuck a little bit, and that's what I was really trying to do. So what we're going to do now is go on into the next section where we're going to use redox reactions to solve a couple of stoichiometry problems. Not crazy complicated stoichiometry problems, just enough to give you a little bit of a flavor for how do you do this type of equation balancing and apply it to calculating something in a stoichiometry type of problem. So make sure you can solve this, make sure you're very comfortable with balancing these redox reactions, and then follow me on to the next lesson where we will continue our journey in learning chemistry.